Hello everyone, let's study and do a chemistry revision on the first chapter, Atomic Structure, by IGCSE.science.notesz on YouTube and Instagram. So basically, an atom is made up of three types of subatomic particles. So subatomic particles are particles, okay, whatever, is the protons, the neutrons, and the electrons. So these are what makes up the atom. As you know that a proton plus a neutron makes up the nucleus, and that electrons orbit the shell in energy or electron shell. So basically electrons orbit the shell in energy or electron shells. So shells have both names, electron or energy shells. And over here we have some important definitions, which are atom, atomic number, and atomic mass. Atom is the smallest part of an element that can exist. And the atomic number is number of positive proton in the nucleus. So it's also the proton number. So atomic number and proton number is the same thing. And they are the number of positive protons in the nucleus. It's the small number. And I'll explain this right now. And the atomic mass is also called the mass number. And it's the total number of protons plus neutrons inside nucleus of an atom, and it's actually the big massive number. So basically, let me explain it this over here. For example, this is a very random numbers. We have 7 and 14, and this is the atom. So atom is the smallest part of an element that can exist, and 7 is the small number as we mentioned over here. So 7 is the atomic number. And the big massive number, let me highlight it in another color. The big massive number is the mass, which comes from massive as well, and mass number in atomic mass, okay, number, which is the big one. So the big one is the massive number, and the small one is the atomic number. And right now we need to know how to find the neutron number. So basically that's 7 and 16. I told you these are very random numbers. 7, as we said, is the atomic number, and 16 is the mass number. So basically mass number, as we mentioned over here, is the total number of protons plus neutrons. So 16 is both protons plus neutrons, and 7 is only proton number. Here, proton number, okay? So you have to know that 16 equals 7 plus n. So basically 16 minus 7 equals n. Okay, so 9 yes, I guess it's 9. Sorry, I think it's 9. Yes, is the neutrons. So part of neutrons equals 9. So basically, let's have it and write it as a rule over here. To find the neutron number, you either mass number minus atomic number, or you do this, which is atomic mass minus proton number. As you can see over here, they are exactly the same thing, but just different names. They are same thing. So over here, we also have to know in the first part, the physical properties of these are the physical properties of the things we just said. So basically, there are 3 subatomic particles, the proton, the neutron, and the electrons. The proton symbol is P, the neutron is N, and the electron is E. So proton, which is P, has mass of 1 and charge of positive 1. And the neutron, which has symbol N, mass is also 1 and its charge is 0. It has no charge. And basically, the electron, which is symbol is E, has mass of 1 over 1840 and its charge is negative 1. And over here we have this this note. Just put it over here. We have to know that an atom has an equal number of positive protons and negative electrons, which make it neutral in charge. Again, so the atom, a normal atom, when it has both equal electrons and both equal protons, it has negative and positive, which makes it 0, which is no charge atom. It's neutral. Okay, the physical properties are very important. Now let's talk about the isotopes. Okay, so here's the definition, which is isotopes are atoms of same element having same number of protons but different number of neutrons. Different number of neutrons means that they have same atomic number but different mass number. And so basically we have some types. We have some types of isotopes. Number 1 is called the radioactive type, and the number 2 is the non-radioactive type, which is isotopes. Okay, so the radioactive isotopes have unstable nuclei. You're gonna know more about it in physics in chapter 5, the nuclear physics, but mainly right now, generally, you have to know that the radioactive isotopes has unstable nuclei, but the non-radioactive isotope are stable atoms, which just really differ in the mass. So really only differ in their mass. So basically, again, over here, these are the types. 1 is radioactive, 2 is non-radioactive. Non-radioactive is the normal one, which really only differ in their mass. However, the non-radioactive is the abnormal one, which is having abnormal nuclei, which is unstable. So basically, again, over here, we have a very important question that we have to know, and it's very, 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 let me write this, very, 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 very important question. So why does isotopes have same chemical properties? Because, or as, they have same number of electrons, or you can also say because they have same electronic configuration. This is a very important question. You can, like, it's very important, it's very common, it's very repeated, you have to know this question. So again, why does isotopes have same chemical properties? Because they have same number of electrons, or because they have same electronic configuration, which is mainly the same thing. Now we get to know some uses of isotopes. They're gonna ask you for industrial uses or for medical uses, or sometimes they just say some uses. So basically, we have here 6 uses, which are: number 1, we use isotopes for checking for paper thickness. We use isotopes to find for leak in pipes. We also use isotopes for uranium fuel in nuclear power stations. We use isotopes for treatment of or for, cancers. And we use it also for irradiating food. And also to sterilize medical and industrial equipments. So basically, again, the uses are very important. You have 6 uses over here. Number 1 is to check for paper thickness. Number 2 is for leak pipes. Number 3 is for uranium fuel and nuclear power stations. And number 4 is for treatment for cancer. Number 5 is for irradiating food. Number 6 is for sterilizing medical and industrial equipment. You're gonna know more about these in chapter 5 in physics as well. Over here is the third part of this chapter, which is periodic table. And you get to know the metals and non-metals and transition elements on the table, on the periodic table, how to you have to know the general points is that on the left there is metals, on the right there is non-metals, in the middle there is transition metals. You have to know where does the metal stop, and you need to know more details. So basically, again, in the first shell, there are shells for the atoms. You have to know that in the first shell can carry only 2 electrons, and the second shell can carry up to 8 electrons. Also, the third shell can carry up to 8 electrons only. For example, the second shell cannot carry 9. It can only carry 8. Okay? The third shell only 8, fourth as well. All shells carry up to only 8, but the first shell carry only up to 2. For example, argon's atomic number is 18, okay? So you can write it as that you have to know 18. The first shell can carry only 2, so 2. Second shell can carry only 8, so it's 8, so it's 10. Now we need more 8, so the third shell carries also 8, so it has 3 shells, and this is its electronic configuration. Okay, so also, for example, let's talk about magnesium. Okay, magnesium atomic number is 12, and so we have 2, 8, 2. I just want to tell you something over here for this 2. I said in third shell it can carry up to 8, not only 8. So it can carry from 1 to 8. And so over here in magnesium, it's first 2, 8, 10. Then we need only more 2. That's why in the third shell it carries 2. But the first shell can never carry more than 2. For example, you can find an atom 2, 1. But you can never find 3, 1. This is completely wrong. It only carries 2. Okay? Okay. Now we have the valency part, which has the group number and the valency part. So let's talk about this. In the valency of group 1, it's positive 1. Valency of group 2 is positive 2. Valency group 3 is positive 3. Valency group 4 is 4. I'm going to tell you something about this. It's special, has a special case, and this also has a special case. Valency of group 5 is negative 3. Valency of group 6 is negative 2. Valency of group 7 is negative 1. And group 8 is unreactive. It has no valency. Its outer shell electrons. So for group 8, it has a full outer shell electrons. Their electrons are full, either 8 or 2, so they have no atoms to transport, to gain, to lose. It's full. And you're gonna know this I'm gonna explain this in details in the second chapter video, which is covalent bonds and this kind of stuff. Just go watch it. So basically, and for the other point for group 4 is that its valency is 4. Okay, but it mainly only shares. Okay, it has nothing to do with ionic it mainly shares. Okay, and I wanted tell you, like, we can call it maybe an exam tip. It's more into how to think and how to really know how to put these. So basically, you have to think of this like that. For example, like elements in group 6 has 6, right? So to reach 8, it needs 2. So valency is -2. And elements in group 5, to reach 8, needs 3. So valency is -3. Let me say this in more details while writing it. So basically, from 1 to 4, their valency is the same as group number. 1 is +1, 2 is +2, 3 is +3, and 4 is 4. Okay, that's for after 5, which is 5, 6, and 7. 5 to 7, you have to know that they are negative. Okay, negative. Okay, the point is, so the full outer shell of electrons is 8, صح? Okay, so think of it like that. 5, to reach 8, it needs 3, so -3. 5 minus 8 is -3. 6, to reach 8, needs 6 minus 8 is 2, so -2. 7 minus 8 is -1, so it's -1. This is how to think of it. Okay. Now let's talk about some important points and write them. Over here, you have to know that all elements in a group have same number of electrons in outer shell, and these are called the valence electrons. So valence electron. Let's talk, for example, about group 2 as an example. And for example, calcium and magnesium. Calcium is 20, magnesium is 12. So 2, 8, 2 here, 2, 8, and 2. Because they are group 2, their valence electrons, both of them is 2. Okay, so you have to know that. Number 1, all elements in a group have same number of electrons in outer shell, and these are called the valence electrons. Point number 2, group number equals number of outer shell electrons, which is, I just mentioned right now, that group 2 is 2. Okay, point number 3, that you have to know that the period number is the number of shells. I'll tell you this right now. So basically, for the third point, which says that period number equals number of shells. So basically, over here is period 1. Oh, this lithium thing is period 2. Sodium is period 3, and we know this, okay? So let's take, for example, period 3, which is magnesium. Okay, so period 3 is magnesium. Okay. And as we said over here, period number is number of shells. So magnesium is 12, and 12 is 2, 8, 2, 1, 2, 3. 3 is 3. That's actually correct. Let's write, for example, another one. For example, let's just randomly pick, for example, oxygen. Okay, oxygen from the periodic table is 8. Okay, so is 8, and so it's 2, 6, so 1, 2, it's in period 2, and 6, it's in group 6. See this? Where is it here? It's in actually period 2. That's actually correct. 1, 2, and it's in group 6 as well. That's actually also correct. So this is the third important. Okay, now the fourth important point, which is if outer shell is full, then it turns unreactive. As we said, group 8 or group 0, which are the noble gases, are noble, they are gentle, they do not react with anyone because they have full outer shell of electrons. And hydrogen has, okay, this is a very important point actually. Hydrogen has protons and electrons, but it does not have neutrons. As you can see over here, it's only one. How can it only be one? It has protons and electrons, which is exactly the same thing, which is, it has atomic number, which is 1, but it has no atomic, it has atomic mass, which is also 1, but it does not have neutrons, okay? Okay. And now we have the last important point for the periodic table, which is that all elements in a group have similar properties. All elements in a group have similar properties. Now let's talk about something called the transition elements or metals. So basically, these are the elements in the periodic table in the middle, okay? These transition elements, you have to know that they are the block of 30 elements in the middle of the periodic table, and they have physical properties and some chemical properties. The physical properties, you're just gonna remember them in the word H or M, okay? They are 4 physical properties. Okay, let's say there are 4 physical properties. We have the letter H, which says they are hard. Okay, they're also strong, and they're also tough. It's just the same point. You cannot write these 3 points as if they are to gain the 3 marks. You're gonna only gain 1 mark. Hard, strong, or tough, the same thing. Okay, you can say it's high melting point, but mercury is an exception. Okay, they have high density and they show magnetism. Let me tell you what is the connection between the H and M and the physical properties. So basically, H is for hard, is for high, and only, okay? And M is for melting and for magnetism. So basically, when you say, for example, list 4 physical properties, you're just gonna say high, so hard, just let me write this in another color, hard, high, melting point, and high density, and also magnetism. Okay, for chemical properties, it's a bit easier, I guess, because chemical properties, you're just gonna make a shortcut in the letter C, so you can remember it easily because C. Okay, now it has C, and C. It acts, no, I'm gonna start it in another color. It acts as a catalyst. It form colored compounds. It forms complex ions. Also, these are some points which doesn't have anything to do with the letter C, but they are much less reactive than group 1 metals. They also form ions with different charges. So basically, all these are all points you have to understand and know in group 1, in chapter 1. Now we're gonna solve some questions from the past papers. Okay, so this is the question I mentioned and I said it was very important. Question number 12. Which statement explains why isotopes of the same element have the same chemical properties? C. They have the same number of outer shell electrons. Why is that correct? Because chemical properties of an isotope determined by the number of electrons in the outer shell is determined. Now, question 13. Why do isotopes of the same element have the same chemical properties? Look at this. They came in two different ways. However, they have the same exact idea. So because they have the same number of electrons in their outer shell. This is letter B. So basically, why is that correct? Because the number of electrons in the outer shell is determined by the chemical properties. Electrons in the shell. Now, let's solve also this. Which properties do the elements chromium, iron, and vanadium have in common? As we can see over here, we choose A because these are transition elements properties. Chromium, iron, and vanadium are transition. They all conduct electricity. Their compounds act as a catalyst. Remember the C chemical, yes. And they all form colored compounds, and that's also correct. So it's A, correct. Now we have the periodic table lists all the known elements. Elements are arranged in order of proton number. The melting points of group 1 elements decrease down the group. The melting points of group 7 elements, I think, I really don't know numbers, I'm sorry, increase down the group. So basically, why is 15C? Because group 1 yes, it's group 7. So because group 1 melting point decreases down the group, while group 7 melting point increases down the group. Why is that correct? Because group 1 is metal, and metal decreases down the group, while non-metal, which is group 7, increases down the group. Okay, you're gonna know more about these in the metal chapter and non-metal chapter, chapter 13 and chapter 8. Okay. Now let's solve the last two questions. Which element is classified as a non-metal in the periodic table? Chlorine, because it's in group 7, and group 7 is a non-metal group. Calcium is in group 2, which is metal. Chromium is in transition elements, metal, so it's metal. Copper is as well as in transition metal, so it's metal. Chlorine is the only group 7, which is non-metal. Now over here, period of the periodic table shown, element Q has a low boiling point, low density, and does not conduct electricity. Which element is Q? Element Q is letter A because it has non-metal properties. Low melting point, low density, and does not conduct electricity. This is metal. Transition metals is metal. Metal, so this is the only non-metal. Let's see, for example, okay, these are the last two questions. Which element is in the same period of the periodic table as silicon? It's sodium. Okay. Same period. Period is this way. Okay. Which pair shows particles with the same chemical properties? It's B, as isotope of the same element. Okay, it's the same element and their isotopes have same proton number but different neutron number with no charge. Different atomic mass number as well. Okay, why is sodium is the correct answer? Because it's in the period 3 and this is the period. And that's it. Thank you so much. Bye bye.